Hi everyone. In this short video I will explain you how to use an underlay timer in CODESYS through a very simple example. So here we have the example in which there is we have one switch which could be closed or opened, and in the program we have one underlay timer which receives the signal from this input or from this switch as its enable bit indeed. We have the time base equal to 1 and preset value of 10, which means that we need to have a delay time of 10 seconds. So while the timer is enabled, or the switch here is closed, we want output B to be energized, and as soon as the input A is false indeed, the output B should be de-energized. As far as timer is timing, output C will be energized, and when the timer is done, output D will be energized. Let's see how can we implement this in the CODESYS environment. I have already created the project where I have chosen the LD as the programming language, and I have added a visualization to that. I'm sure you all know how to do this. So let's start by developing the code for our project. We need to start by inserting a normal contact and associating it with input A. It should be a Boolean variable, and it will be declared here. Then we need to insert one underlay timer. To insert the underlay timer, we can insert a box and put it here just after the input A contact, and then here we need to determine that this box is a underlay timer function. To that we just can click on this two dots here and wait for the input assistant, and here, yeah. So in the standard library we have this timer option here, and since we are going to use one underlay timer, we need to click on this. After clicking, selecting and then pressing enter, we need to declare it as well. So pressing on enter again, we have this auto declare window in which we can choose a name for our timer. We can keep it as default, and here we have the type of the variable in it, which is T on or underlay timer. Clicking on OK, you can see that it will appear here. So for this underlay timer, we need to provide one input which comes from the switch, indeed input A, and it's indeed enables or activates the timer. We need to determine a preset time here. For that we can associate a variable, or we can type the value here directly, and we want to have 10 seconds. So the format is to type T hashtag 10s. This means that we will have 10 seconds of delay, and for elapsed time we can use it, or we can just remove these dots from here. Now with this piece of code, whenever the input becomes true, the timer will start timing, and after 10 seconds its output will become true. Okay, so if we go back to the here to the program that we had, we need to have three outputs. Output B will be associated with the enable bit of the timer, output C with the timer timing contact, and output D with the done bit. So output B and D are very straightforward. Going back to our CODESYS, if we introduce a new network below, I just need to insert a contact here and then one coil. The coil will be associated with output B. Okay, so here we need to be careful, because if you pay attention, output B now is declared as an integer variable. It means that by default it was set to integer, and I didn't pay attention and just declared it in this way. If I want to build the code indeed, I will receive an error here, so I need to change this into Boolean. And this contact should be associated with the timer enable. And to do that, we just need to again go to the input assistant. We have this T on underline 0 timer, and I can pick the input of the timer, which is enable bit of the timer. And clicking on that, you can see this T on underline 0 dot in, or input, is associated with the output pin. Inserting another network, doing the similar thing, associating this with output D, and here choosing Boolean. Now I need to associate this with the done bit of the timer. For that I can just type T on underline 0 dot, and you will see all the possible indeed possible fields that we can have here, but what I need is this T on dot Q, which is the done bit of the timer. Now we need to have another network, and if you pay attention here for output C, we need to have the timer timing bit of the timer, but in CODESYS we don't have that. Indeed, our timer doesn't include such property. However, we can just make it. Timer timing means that the timer is enabled, but it is not done. So we can make this indeed by referring to the input and Q bits of the timer. So I want to have, let me just insert output C here as well as a Boolean variable. So I want to have the timer enabled. So again here timer in, but not done. So T on underline 0 dot Q. So this means that the timer is enabled but not done. It means the timer is still timing. In the visualization we need to have one switch and 3 pilot lamps. I will use this deep switch, and the deep switch will be associated with the input A. So it should be here. Yeah, input A, and I need to have 3 pilot lamps. And associate them with output B, C, and D. Output B, output C, and output D. So what we expect here is that when we run the program, changing the state of the switch from false to true, we want to have output B turned on. As far as the switch is closed, output B will be turned on. Then when after 10 seconds of closing the switch, output D will turn on, and during those 10 seconds output C will be turned on, and then it will become turned off indeed. Let me put it in the simulation mode, put the project in the simulation mode, and then do the login. We may face the issue with the visualization. If it happens, then I would need to log out and let's see. Okay. Yeah, we have this program loaded exception. I need to log out, go to the properties of the application, and in the build I need to type visual no exception handling. Save login with download to have all the changes that we made here be effective, and then run. And now we see the visualization. I just put it here besides the program. So as far as I haven't changed the state of the input A, you can see that its value is false. As a result, timer does nothing. Its output is false, and since it is not timing, all the outputs are false. We can also see these variables for the timer at the same time. So now if I change the value, you can see that the output B is turned on. If I switch it back, output B will turn off. And if I do it again, for 10 seconds, this second output C indeed, will be turned on. And after 10 seconds, it will turn off, output D will turn on. So let's wait. Okay, yeah, now that happened. Now this is turned off and the output D is turned on because the timer is done indeed. And it's not timing anymore. And its input is still energized. It receives input signal. That's why the enable bit or input bit of the timer is true. If I switch it back, all of them will go false, and again the same scenario will happen after 10 seconds. Okay, yeah, I think that's all for this video. I hope that it would help you in understanding the behavior of the on-delay timers and how to implement such programs in the CODESYS environment. Thank you for watching and see you next time.